So we're back doing a few more examples using the chain rule to differentiate composite functions. But this time, let's take it up a notch. Here's a little reminder of the chain rule. If y equals f of g of x, then dy dx is equal to f prime of g of x times g prime. Or if you'd rather think of it this way, dy dx is equal to dy du times du dx. In this example, we want to find the slope of the line tangent to the graph y equals ln of x squared at x equals e squared. Remember that the slope of the tangent line is simply the derivative. So we want to find the derivative of y when x is equal to e squared. We can use the chain rule for this. Our inside function u is equal to x squared, and our outside function y will be equal to ln u. So dy dx is equal to the derivative of y with respect to u, which is 1 over u, times the derivative of u with respect to x, which is 2x. Replacing u with what it's equal to, 1 over x squared times 2x, which is 2x over x squared, which is 2 over x. So when x is equal to e squared, dy dx, when x is equal to e squared, is equal to 2 over e squared, which is the slope of the line tangent to the graph of y equals ln of x squared at x equals e squared. But wait, since this involves logarithms, I could probably do this a completely different way. I'm going to look at y equals ln of x squared. Using properties of logarithms, I can rewrite this as 2 ln x, and now I don't need to use the chain rule at all. Dy dx is equal to 2 over x, so the derivative with respect to x when x is equal to e squared is equal to 2 over e squared. Notice that even though we use two different approaches, we got the exact same answer. Let's move on to another example. In this example, y is equal to the cosine squared of 3x. Remember that you could also write it this way, cosine of 3x quantity squared. This time, this is the composition of 3 functions, not just 2. The first function is multiply the input by 3. So let's say u is equal to 3x. The second function is to find the cosine of the result. So let's say that v is equal to cosine u. And then we're going to square the result of that. So let's say that y is equal to v squared. Those are our 3 functions. Let's take the derivatives with respect to each variable. So the derivative of u with respect to x, du dx, is equal to 3. The derivative of v with respect to u, dv du, is equal to negative sine u. And the derivative of y with respect to v, dy dv, is equal to 2v. Notice that if I multiply these 3 derivatives together, I'm going to write them in the reverse order of how I have them written here. Dy dv times dv du times du dx. If we treat them like fractions, they're not really fractions, but we're going to treat them that way for the sake of illustration. Notice that the dv's cancel out, and so do the du's, and I'll be left with what I want, which is dy dx. So dy dx is equal to 2v, that's d by dv, times negative sine u, that's dv du, times 3, that's du dx. Remember that v is cosine u. So this is 2 cosine u times negative sine u times 3. And remember that u is equal to 3x. 2 cosine 3x times negative sine of 3x times 3. So we can write this as negative 6 cosine of 3x sine of 3x. And that's the derivative of our composition of three functions. We have one more example to look at. In this example, the function g is defined by g of x is equal to f of x quantity cubed. If f of 3 is equal to negative 5 halves and f prime of 3 is equal to 4, we want to find the slope of the line tangent to the graph of g at x equals 3. Now we should know that the derivative is equal to the slope of the tangent line. So what we really want is g prime of 3. Since g of x is defined here as the function f of x cubed, then g prime of x will involve the chain rule, where u, the inside function, is f of x, and the outside function, which we've been calling y, is u cubed. So g prime of x is going to equal 3u squared, the derivative of y with respect to u, times f prime of x, the derivative of u. Substituting u with what it's equal to, 3 times f of x squared times f prime of x is the expression for g prime of x. Now let's evaluate that derivative at x equals 3. G prime of 3 is equal to 3 times f of 3 squared times f prime of 3. Substituting the values that they gave us, 3 times negative 5 halves, which is f of 3, times 4, which is f prime of 3. Squaring negative 5 halves, 3 times 25 fourths times 4 is equal to 75. And 75 is the slope of the line tangent to the graph of g at x equals 3. Now it's your turn to do some more examples where you need to find the derivative of a composite function to answer a slightly more involved question.